So now we are recording and going to go back to sharing that. And as I mentioned, today we're going to be, or I didn't mention this, but today we're going to be covering section 3.7. Again, going back to this. So we're recording this. So if you don't want your face or name to be out there, please leave your video off and use an alias name. Any questions about that before we go on? Okay, so, whoops, wrong one, sorry. So today we're going to be covering section 3.7, which has to do with graphing linear inequalities. And I'm going to start by reviewing basic things we do with equations and then inequalities. So first of all, let's say we have x plus 3 equals 7. What would we do to solve this equation for x? Anybody? And if you don't want to respond, that's fine. I'll just respond myself.
Subtract 3.
Subtract 3. So if we subtract 3 from both sides, we get x equals 4. Great. All right. Now, what if we have x plus 3 is less than 7? It's the same thing. We subtract 3 from both sides, and we get x less than 4. Any questions about that? All right, let's say we have y minus 2 equals 14. What would we do here to solve this equation for y? We would add 2 to both sides of the equation and get y equals 16. Any questions about that? All right, likewise, if we had y minus 2 is greater than or equal to 14, to solve this inequality, we would do the same thing. We would add 2 to both sides and get y is greater than or equal to 16. Any questions there? All right, let's say we've got 4x equals 12. What would we do to solve this equation for x?
You would divide both sides by 4.
Excellent, and you would get x equals 3. Suppose we had 4x is less than 12. What would we do?
The same thing.
Same thing. Excellent. And we would get x is less than 3. Okay. And if we had, let's say, x over 2 equals 10, we'd multiply both sides by 2 and get x equals 20. If we had x over 2 is greater than 10, we'd multiply both sides by 2 and get x is greater than 20. If we have decimals, we can clear them by multiplying both sides by 10 or 100 or 1,000. If we have fractions, we can multiply by the least common denominator, all that stuff. But when we're dealing with inequalities, there's one thing that's different. One thing we've got to watch out for. Does anybody remember what that is? Well, let me tell you. Let's say we've got negative 2x is greater than 10. To solve this inequality, we would divide both sides by a negative number. If you divide or multiply both sides of an inequality by a negative number, what do?
You flip over the sign to...
Flip over the sign, right. So that's the thing that's different about inequalities from solving equations. That's the big thing you've got to remember. If you multiply or divide both sides of an inequality by a negative number, change the direction of the inequality sign. Okay, so that's just kind of a brief review of that. If you need an extensive review, this was covered back in a previous class, and it's in section 2.7. Yes, 2.7. All right. Now, let's say we've got a linear inequality in 2 variables. X minus y is greater than 4. Okay? And we want to graph this thing. All right? There are a couple of different ways we can go about it. And what I'm going to do now is I'm going to switch to a different screen. So give me just a minute here. Let's see if I can find my mouse. There it is. So we're going to close that up. And we're going to open up this screen. And here. All right, can everybody see it's a graph screen and it's got a grid over on the right side?
Yes.
You can see it. Okay, just want to make sure I did everything correctly. Okay, and let's see, what did I say? I said, was it x minus y is greater than 4? All right. So what we're going to do first of all, we're going to look at the related equation, x minus y equals 4, okay? So we're going to consider that, and we're going to graph that. Now, there are 2 different approaches that we can use for this problem. In fact, all these problems we're going to look at. I'm going to do it one way, then I'm going to come back and do it the other way. The first way I'm going to do it is the way that I prefer, and that is by putting this equation in slope-intercept form, y equals mx plus b. Do you remember that? Where m is the slope of the line. Oops, I said plus b and I wrote plus 4. And b is the y-intercept. So this should be, hang on here, let me get that out of there and write it a little better. Okay. Anyway, y equals mx plus b, where m is the slope and b is the y-intercept. So to do that, I have to take this equation and solve it for y. So I've got x minus y equals 4. I'm going to subtract x from both sides. And then I'm going to divide everybody by -1. So I'm going to get y equals x minus 4. All right. So are you okay with that? Any questions how I got from here to there? All right. So slope-intercept form, what would the slope be?
1,
1, correct. And the y-intercept?
-4.
-4. All right. So now, if I was going to graph this equation, I would start at a y-intercept of -4. The slope is 1, so I would go up 1 and over 1, etc. Now, if I was graphing the equation, I would draw a solid line through those dots. However, if I go back to my original problem, I'm not graphing equals to, okay? So in fact, let's take this inequality and let's solve it. All right, so let's see, I'm going to subtract x from both sides, -y greater than -x plus 4. Divide everybody by a -y. Oh, change the direction. So I get y is less than x minus 4. Okay, are you still with me? Hopefully. So y is not equal to x minus 4. That would be the line going through those dots. But in fact, y is less than that. So I'm going to take a straight edge here and just kind of extend those dots a little bit. Where would less than x minus 4 be? If this line, this dotted line represents y equals x minus 4, where is y less than that? It would be below the line. Some of you have got noise going on in the background, so could you turn off your microphones, please, unless you have a question, so that that noise doesn't come through. Thank you. All right, so our solution is everything below, but not including that dotted line. All right, think of it this way. Do any of you have a neighbor next door and there's a fence between your property and theirs? Anybody have that situation? Nope. Okay, but do you understand what I'm talking about? So you've got side-by-side neighbors and there's a fence dividing the property. Well, that's what's going on here. But this person that's got this stuff here, they don't own the fence. So their property consists of the stuff that I've shaded in here, okay? But the fence draws a boundary line, but they don't own it. I'm going to make a subtle change to this problem. In fact, let's change colors just to highlight what I'm going to do. I'm going to change it to where it's x minus y is greater than or equal to 4. So this would put an equal to, and this would put an equal to. So now, in this case, you do own the fence. So it would be everything down here, but this would be a solid line going through those points. Okay, because the solid line is the equal to part, and the shaded part below it is the less than part. Does this make sense? Do you have any questions about this?
That makes sense. Thank you.
Okay. Now, I'm going to go back and do this same problem again, do it a second time, but use the other method. Okay. So let's change this to black, and let's go on to the next page. X minus y greater than 4. X minus y greater than 4. All right. Another way to do this problem, if you don't like using slope-intercept form, again, oops, that's not what I wanted. Think of it as like being an equation. So we're going to get a straight line, okay? But what I'm going to do is I'm just going to find some ordered pairs. Actually, I only need a couple of them. How about if we let x equal 0 and we'll let y equal 0? So we'll go after the intercepts, okay? Remember what I mean by the intercepts, the x and y intercept? Okay. So if x is 0, we get 0 minus y greater than 4, negative y greater than 4, divide by negative 1, y is what? Less than negative 4. But that's not going to work very well, is it? Because I've got y is less than negative 4. So let's rethink this. Let's go back. And again, let's think in terms of an equation. X minus y equals 4. Okay. Now, if I solve an equation, I get 0 minus y is 4. Divide both sides by negative 1, y is negative 4. So 0, negative 4 is a point on the equation. Let's see, 0, negative 4, that's right there. If y is 0, I get what? X minus 0 equals 4, so x equals 4. So I've got 4, 0. So I've got those 2 points that are points on this line. But again, my actual situation is not equal, it's greater than. Okay? So because it doesn't include equal, it doesn't include the line. So I'm going to draw a dotted line. All right? You still with me?
Yes.
Yes.
All right. Now I
Yes.
need to determine which side of the line the solution is on. Okay? When I don't do it slope-intercept form way, I have to do this. I have to pick a test point. You don't want to pick something that's on that dotted line. An easy point to pick would be the origin, 0, 0. So I'm going to plug 0, 0 in here and see if that makes it true. Is 0 greater than 4?
Nope.
So this point is not part of the solution, which means that the solution is on the other side of the line. Okay? And if you're a little uncertain, pick a point over here. How about, let's see, that would be 7, 0. Okay? If I try 7, 0, 7 minus 0 greater than 4, 7 greater than 4, That's true. That points to the solution. So my solution is everything below the line. Okay. So this method, you use slope-intercept form. Keep in mind that I changed this to equals as well. This method, you find a couple of points, draw your line, but if it doesn't include the equal to, it's just going to be dotted. Then pick a test point on one side or the other. If the test point is true, then that's the correct side. If the test point is false, then the correct side is on the other side. Okay. All right. So that's the main information. So what I'm going to do now is just continue to do some more examples, and I'll do it either method that you want. Let's see here. Let's go on to the next page. Let me put on my glasses so I can see something. Earlier, in case you were just now joining us, I mentioned several people have not signed up for WebAssign yet, and if your email is not the one that was listed at the school website under students and everything, then you need to email me at bmail@ybcc.edu so that I can give you all the information for the class, because the assignments are on WebAssign. And when I checked early today, only half the class had even signed up for it. So you have an assignment tonight, you have to do it on WebAssign, it's due tomorrow. So we need to get you going on that. All right, anyway, enough nagging. Let's take a look at this one. 5x plus 4y greater than or equal to 20. All right. I don't know if it's going to be confusing to you for me to jump back and forth between the two methods. Here's what I think I'm going to do. I'm going to use the slope-intercept method. When I'm done with it, if anybody wants me to go back and use the just plotting points method, let me know, wave at me, yell at me, something, and I will go back and do it that way. All right? So here we've got 5x plus 4y greater than or equal to 20. I'm going to put this in slope-intercept form. So I'm going to subtract 5x from both sides. I get 4y greater than or equal to negative 5x plus 20. Next, I'm going to divide each term by 4. So I get y greater than or equal to negative 5/4 x plus 5. Thinking in terms of slope-intercept form, the slope would be negative 5/4 and the y-intercept would be 5. Any questions about that yet? All right, so that means it passes through the point 0, 5, and the slope is negative 5/4. So as we go from left to right, we're going to go down 5 and over 4. Down 5 and over 4. And let me move that picture out of the way there. I don't know if, here, we'll put it over there. Okay, now the question is, do I want to draw a solid line or a dotted line? Well, if I go back here and look, this says it's greater than or equal to. It's greater than or equal to. So the equal to part would be a solid line. So I'm going to draw a solid line. Okay. Now, it says y is greater than or equal to. So where is y greater? Would it be below or above that line?
Above.
Above, correct. So our solution, you'd shade everything above, and it's your fence as well, okay? Here's the neighbor down here. It's your property's up here, and you own the fence. It's included because it's y is greater than or equal to. All right, would you like me to go back and do this same problem using the finding the points method? Anybody?
No, that'd be fine.
Okay. All right, and I'll go on to another example.
have a question.
Yes.
I started on the WebAssign, and I'm having trouble how to shade that
Yes.
in there.
I'm going to talk about that. I'm going to do a couple more examples, and then I'm going to bring up WebAssign, and we'll go through and talk about all of that. Yeah,
Okay.
because I know it's kind of tricky. I myself struggled trying to figure things out with it, but I think I've got it down. So give me just a couple more examples, and then we'll take a look, all right?
Thank you.
Okay, and if I forget, you remind me.
Okay.
Okay, let's see here. How about this one? Y is less than x over 3 minus 1. This inequality is already pretty much in slope-intercept form. I'm going to tweak it just a little. X divided by 3 is the same thing as 1/3 x, isn't it? In other words, there's an implied 1 there, so our coefficient is 1/3.
Yes.
This is already in slope-intercept form, so the slope is 1/3, and the y-intercept is -1. So over here, we're going to plot the point 0, -1. Our slope is going to be up 1 over 3. Up 1 over 3. Now, is my line going to be solid or dotted?
Dotted.
Why is it dotted?
Because it's not equal to.
Correct. Good. Let's see if I can. All right. Now, it says y is less than, so we're talking shading below the line. So again, in this case, it's not our fence. It's our property below the fence, but the fence belongs to the neighbor, so it's not included in our property. Are you okay with that? Any questions there? We good to go on to another example?
Yes.
All right. How about this? Y is greater than -3. There's no x in this. Think back to beginning algebra when you were learning to graph lines. Can you tell me what y equals -3, what that line looks like? Anybody?
It would just be a straight line through y, wouldn't it? Through the -3 value of y.
So how would that look? Would it be a diagonal line, vertical, horizontal, what?
Vertical.
Horizontal.
All right, I heard vertical and I heard horizontal. One of you is right. Think about this. If y equals -3, that means every point on the line has to have a y value of -3. So that would be, whoops, I missed it there. That would be a horizontal line. Does that make sense? If it was x equals -3, that would be a vertical line. So our line, let me go back here and try and do a better job here. Now, why did I draw it dotted?
Because there's no greater.
Because it's just greater, it's not equal to. So are we talking above or below the dotted line? Y is greater than -3.
It would be below because y is greater than.
But if this is y is -3, where would a greater y value be?
Above.
Yeah, -2 is greater than -3. Are you thinking -4 would be greater?
Not really sure. Just
Okay,
kind of
okay.
refreshing.
Time out. Let's think about number line, okay? Just number line. -1, -2, -3, -4, 1, 2, 3, etc. Okay, so -3 is here. Is -4 bigger or smaller than -3?
Smaller.
Yeah, think of it this way. If you're in debt $3 and I'm in debt $4, who's better off?
3.
the -3, being in debt $3. So as we go to the right, the numbers get larger. So -4 would be more in debt than -3, but larger would be more positive. So you're better off to be $3 in debt instead of $4 in debt. So greater than -3 would be above. Is that making sense?
Yes.
Okay. Less than would be below. All right. One more example, and then we'll go to the WebAssign stuff. Okay, let's see here. X greater than or equal to -4. So what does X equals -4 look like?
It'd be a vertical line.
Passing through -4, and it's going to be a solid line because it says greater than or equal to. Now, this problem doesn't have y in it, so we can't go above or below, but where is X greater than -4? Would it be to the left or to the right of that?
To the right.
To the right, correct. So here, it's everything to the right, and it's our fence because it's a solid line. All right, does that make sense?
Yes.
All right, any questions before I close this all down and open up WebAssign and look there? All right.
Mr. Mayo,
Yes.
I didn't assign for WebAssign yet, but I don't know how to do that.
Okay. So did you get my email with all the stuff?
Yes, I got your email.
Okay, so here's what I want you to do, okay? Email me.
Okay.
When I'm done with classes this afternoon, I will go through and look at everybody's email. And if you aren't signed up yet, I will call you. Do I have your phone number?
Yeah, you called me
Okay.
before.
Okay, I'll call you up and walk you through it and make sure, because I sent all that information out, but people are having troubles getting it to work. So just email me, say, hey, I'm not signed up yet, help, and I'll get in touch with you, okay?
Okay, thank you.
You bet. All right, but you'll still get to see what's going on here with WebAssign. Okay. Any other questions before we go on? All right, so I'm going to close this down, and let's see here. Let's get that over here. And that up. That. Oops. Hang on here. Okay. And let's go student view and pick one of those. All right. Have I got the WebAssign on the screen?
No,
I don't.
not that I can see.
Okay, so let's stop sharing and let's go back in here and let's share that. How about now?
Yes.
Yes.
So you can see it says graph the inequality,
Yes.
x plus y is less than 8.
Yes.
Okay, great. Every time I think I've got it figured out, I don't. One morning I had the volume on my speaker turned off and I was going along and somebody said, finally somebody texted me that knew my phone number and said, people are asking questions and you're ignoring them. It's because I had no idea because I had the sound turned off. Duh. Oh well, I'm learning. Okay, graph the inequality x plus y less than 8. So the first thing we're going to do, because we've been doing slope intercept form, and I'm going to do this off to the side where you won't be able to see it, but I'll just walk you through it. Okay, so if I've got x plus y is less than 8, I'm going to subtract x from both sides. So I'm going to have y is less than negative x plus 8. Does that make sense? Y is less than negative x plus 8.
So far, so
Yes.
good.
Okay, so the slope would be -1, and the y-intercept would be 8. Are you okay with that?
Yes.
All right, now watch closely because it's kind of tricky. You have to get used to it. So what we're going to do, we're going to graph a line. Ultimately, it needs to be a dotted line. Can you see my cursor, mouse moving around?
Yes.
It is.
Yes.
All right. So I'm going to go over here to the left, and I'm going to click on the arrow. And I'm going to click on it again until it turns blue. Okay? Like over here, one click doesn't do it. You got to click on it a couple times. So I want this line to be solid blue. Okay? Now, the y-intercept is at 8. So from here, I'm going to go and click on 0, 8. Okay? The slope is -1, so I'm going to go down 1 and over 1, and I'm going to click there. Then I'm just going to click again, so that gives me a solid line passing through those 2 points. Any questions so far? Now, recall that our inequality is y is less than -x plus 8. So I'm going to go over here and click on the line, not the x. I don't want to delete it. I'm just going to click on this line. And I want you to notice a couple of things. First of all, here are the coordinates of the 2 points that I plotted. And here I can change it to a dashed line. If I click back here again, there I have my dotted or dashed line. Okay? Do you need me to repeat any of that before we go on? So now I've got my dotted line. It was y is less than -x plus 8. So less than, would that be below the line or above the line?
Below.
Okay, so I'm going to click on fill, and then this obnoxious sign keeps coming up when I'm just going to say okay, and I'm going to click down here. So I think I'm done. I've got a dotted line passing through 0, 8 and 8, 0. I've shaded below the line, so I'm going to go submit answer. And it says it's correct. All right. Any questions about that? Does anybody want me to go back and do this problem the other method where you find 2 points rather than using slope-intercept form? Okay, fine. Let's go on to the next problem. So we're going to do the same thing. We've got 9x minus 8y greater than 24. Okay. I'm going to try something here. Let's see what happens. I'm going to minimize this, and I'm going to open up this and scroll down here. And now, let's see, I'm going to stop sharing and then share. And let's see here. Can you now see where I'm scribbling on the board?
Yes.
Okay, great, great. All right. So we're going to take 9x minus 8y greater than 24. Okay? And we're going to put this thing in slope-intercept form. So I'm going to subtract 9x from both sides of the inequality. Okay. Then I'm going to divide each term by -8. So I get y. I'm going to change the direction of the inequality sign because I'm dividing both sides by a negative number. Negative 9x over negative 8 would be positive 9/8 x. And then plus 24 over negative 8 would be minus 3. So that means I'm going to have a dotted line. The slope is going to be 9/8, and the y-intercept is going to be -3. Any questions about that work before we go back to the WebAssign page? All right. So now let's see if I can do that okay. I'm going to go back here and share and screen 1. Okay, can you see the WebAssign now?
Yes.
Thank
Yeah.
you. All right. Because I wish there was a place out here that I could write the work and everything so I wouldn't have to keep switching back and forth. But if there is, I haven't figured out how to do it. So we're going to go back here. I'm going to click on that twice. Oh, while I'm here, I want to point out, this is not a line. That is a ray. It has a definite endpoint and then goes off in one direction. This is not a line. It's a line segment. It has definite endpoints. Because I've had students use these and wonder why it was wrong. We're graphing a line, okay? So I've got it to where it's blue. Now, the y-intercept from our work was at -3, and the slope was 9/8. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 8. Okay? So there's my line. But recall, it was y is less than. So I'm going to go here, make my line dashed. So where would less than be? Would it be above the line or below the line?
Below.
Below the line. Let me just show you what happens if I do it wrong, okay? So I'm going to put it up here, and I'm going to go in here and I'm going to submit the answer, and it says, oh, it says it's wrong. So I'm going to go back. Let's see here. I could start all over, or I could just go back here and say, you know what, I'm going to redo the fill, and it's over here, and now submit the answer. And now it says it's correct. All right, are you okay with that one?
Yeah, but question of curiosity, how many attempts do we get?
So for the homework, you basically, I think I've got it listed as 100. And if you use those, you might want to rethink your life. But yeah, so you should have no trouble. But again, the idea isn't just, well, I'll just keep clicking different things until I come up with the right answer. Because on the test, you get two tries, which I personally I think is generous, but that's what one of my colleagues who's been using this a long time, they said they give them two tries because sometimes people enter the wrong things accidentally, maybe. So you got to know your stuff before you take the test. And while I'm on that, just the test is timed. Once you start it, you have 90 minutes, which again is a lot of time to finish the test. Homework, you can open it and work on it and close it and go back later up until it's due always 11:59 p.m. the next day kind of thing. So tonight's homework assignment is due, you have to be done by Tuesday at 11:59 p.m. because after that it goes away and you can't access it. That doesn't mean wait until tomorrow to do it, because what's going to happen tomorrow, I'm going to start class by saying, are there any questions from last night's homework? So if you haven't done it yet, you won't know what it is you don't know. Does that make any sense?
This all makes perfect sense.
Good, good. Because what I've had people do is I'll have people that'll wait till tomorrow at 10:30 p.m. and then they'll start the assignment. And I'm like, you're getting close to the fire there. You don't want to do that. All
Mr.
right.
Mayo,
Yes.
so is it the homework going to be from the book, or is it going to be online? Are we going to use
Everything
the
is
book?
online. Okay. And this is why I sent out all this information, but about half the people didn't read it. Online, you go to the Cengage website that's in the emails I sent you, follow the directions that I wrote, it's $60 if you just want to use the ebook online and access the homework and the tests like we're looking at here. If you want to have a loose leaf copy of the book, then I think it's like $69. You still get all the WebAssign stuff, plus they'll send you a book, like if you want to take notes on it. But there's no need for you to buy the hardbound book unless you really want to spend the money. Okay?
Okay.
And again, if you can't find an email that I sent that has all that information, email me, let me know, and I'll contact you and we'll walk through it. All right?
Okay, thank you.
You bet.
So I have one question.
Yeah.
Sorry, I hope I didn't interrupt you.
No, that's fine.
Okay, I have one question. Well, so I got the I got the loose leaf copy of the book.
Yes?
If I have the book, I still need to get WebAssign, right?
Yes.
Okay. Yes, I think it's because I had after reading your email, I had gone to the Spanish syllabus, and then I had kind of overlooked that part. So yeah, I'll definitely do that.
Yeah. So really, this should have been $60. If you spent more than that, then you spent more than that. But I mean,
Yeah.
unless you want a copy, if you want the hard copy of the book. Okay.
Yeah,
We've got a
okay.
little bit more time. Let's take a look at this one. Okay. If we're good to go on to another one. Let's see, 2x plus y greater than or equal to -4. So I'm going to minimize that. And let's see here, stop sharing and go back and share that. So now, can you see my white screen?
Yes.
Yes.
Great. 2x plus y greater than or equal to -4. So I'm going to subtract 2x from both sides. I'll get y is greater than or equal to -2x minus 4. So it's already in slope-intercept form. The slope is -2 and the y-intercept is -4. We all right with that?
So
Yeah.
far, so good.
Okay, so now we'll go back and share the WebAssign screen. So I'm going to click on the line till it turns blue. I'm going to click on the y-intercept of -4. The slope is -2, so I'm going to go down 2 and over 1. Click there to make it solid. Now, this was y is greater than or equal to, so that means I want to leave the line solid. Where is greater than? Is it over here or over there? Here or there? Here or there?
Gonna go with there.
There it is. Okay, fill. Okay, click on it and then submit answer. And it says, yes, it is correct. Again, I want to point out, if you get like a weird ordered pair, like let's say the y-intercept is like -2/3, and you're not quite sure if you're plotting it right, after you plot it, again, you can come in here and you can change your coordinates of those points if you need to. Okay? So let's see here. What did we have? We had it was above, right? You okay with that?
Yes.
Okay. Let's see here. Let's do this one, number 18. It says y is greater than -8. So y equals -8 would be a vertical or horizontal line? Where would all the y values be -8? Wouldn't it be down here?
Horizontal.
Horizontal,
Yes.
okay. So let's see, I'll just put a point here and then here. And except that I want this to be dotted or dashed, I guess is what they're, same thing, okay? So y is greater. Is it below or above? below, or above? Which one?
Above.
Above. Fill. Above. Submit answer. Yay! Okay. Oh, let's look at this one, because this one's going to be a little bit tricky. All right? And then we'll call it a day, except I'll be back for my office hour at 1:15. But let's see, if I've got x minus 1.9 less than or equal to 0, if I add 1.9 to both sides, I'm going to have x less than or equal to 1.9. Are you okay with that, or do I need to switch screens to show it? Anybody?
I'm okay.
Okay. All right. So I need to graph. Wow, at 1.9. Notice how it jumped to 2, didn't it? So I'm going to come over here and I'm going to change that to 1.9. And I'm going to change that to 1.9. Do I want it to be solid or dotted?
Solid.
Gotta be
Oh.
solid.
Okay. And let's see, it was x is less than or equal to, so am I going to be on the left or the right?
The left.
Left.
The left, good. Okay. But again, did you notice that when I went and plotted those points, it automatically jumped to the 2? It's like it wouldn't let me do that fraction. So that's why, or that decimal, that's why I had to go in here and change it around, okay? So working with this is a little bit tricky. So you gotta, which is why some of you that tried earlier had trouble with it. It took me a while to figure it out myself. And I'm still wondering about some things that last quarter didn't work. And in this quarter, I was gonna warn everybody, but then it started working. So I don't know, we'll see. All right, so I'm going to go in here and stop the recording.